In this video, we'll be going over and introducing the imaginary unit and complex numbers. Go ahead and pause the video and try these 3 review questions on your own, and then we'll go over them. And here we go. So with the first one, first radical here, notice how it's in fraction form. So I could also write this as the square root of 108 over square root of 25. Then recall, right, that the square root of 25 is 5. Now keep in mind, I'll keep my positive negative here. So here we've got 5 in the denominator. Now we've got the square root of 108. That can be simplified. So I'll go ahead and do the prime factorization. Well, I know that it's even, so it can be divisible by 2. So 108 divided by 2, so that would give me radical 54 times radical 2. Now notice how 2 here is prime, so I can, we're good to go with simplifying this radical. However, radical 54 can be simplified and broken down even more, right? So I could use radical 9 times radical 6. So now that I've broken down 54 here, I've now broken that down. Then I can break both of these down. Well, radical 6 can be broken down to radical 3 times radical 2. So notice how here, now I have both prime factors. Then here for radical 9, radical 3 times radical 3. Notice how here is our pair, but also broken down to prime. Now, remember when taking out, when simplifying the radical, you take out pairs. So notice how we have a pair of 2. So here I've got 2. You also have a pair of 3s. So I have 2 times 3. Then we do have our one last radical here. So we have here still radical 3. And 2 times 3 is 6. So 6 radical 3 over 3. Now I'll also show you another way, which is using when you're coming up with factors, but using the perfect square as a factor. So remember, perfect squares are 1, 4, 9, 16, right? So that's 1 times 1, 2 times 2, 3 times 3, and so on. So here we've got radical 25, right? Because that'll give you 5, or 5 times 5. Here is 36, 49, and then 8 times 8, 64. I'm just going to keep on going. 81. I'll stop here at 10 times 10, which is 100. So again, breaking down and simplifying 108. So if I have radical 108, if I were to test out, starting from the largest of my perfect squares, which of these values here is a factor of 108? Well, there is 9, but there is also a factor greater than 9, 36. So I'm going to go ahead and 36 times 3. So radical 6 times radical 3. Now, because what is the square root of 36? 6. So 6, then radical 3. So notice how you'll get the same. So then here, if I were to break down square root of 45, right? So radical 45. Now, keep in mind, you are multiplying by 6. So I'm going to still continue and bring down my 6 here so I don't forget to multiply by that 6 at the end. So with radical 45, I can break that down to 9 and 5, right? So my two factors here, because the square root of 9 is 3. So I've got 3 radical 5, but remember, right, bring down that value of 6 here, that coefficient. So now I've got here 6 times 3, so positive negative 18 times radical 5. So now let's go to the last one. And again, notice how we have 1/2 as that front coefficient. So keep that in mind and bring it down so you don't forget to multiply that at the end here. So now with radical 48, I can break that down using perfect square factor. If I look above here, I could use 16. So now I've got radical 16 times radical 3. So because the square root of 16 is 4, I've got 4 radical 3. But don't forget, right, to multiply that by 1/2. half. So now this becomes positive negative 2, radical 3. So now let's look at the graph here of our quadratic function. So x squared plus 1. And notice and remember, right, when we were looking for the real solutions or solutions of a quadratic, we're talking about the x-intercepts, or where the graph here is crossing the x-axis. Well, notice, is our graph crossing? Does it have any x-intercepts? No. So how many solutions does this have? It has none. It has no real solution because it's not crossing the x-axis. Then let's go ahead and solve our quadratic here as if we were solving for x. So I'm going to go ahead and solve for x here. So I'm going to subtract 1 from both sides. And I've got negative 1 is equal to x squared. Then, of course, we take the square root. So that here, now notice, we're left with x is equal to the square root of negative 1. And can you take the square root of a negative? No. So if you think about it, right, can we, if we can't find, if there's square root of negative 1, does it have any real solutions? No, because here, looking back at the graph, right, how many real solutions does it have? It has no real solution. So with square root of negative 1 representing no real solution, this is now where we see and begin the concept of imaginary numbers. So again, the imaginary unit I is defined as that square root here. So sorry about that little symbol, but the square root of negative 1. So really, if you also wanted to write the solution, this would be that positive negative I. So notice how the square root of negative 1 is I. That is our imaginary unit. So now looking at these examples with our radical here, right? So again, I'll focus on those perfect squares. So I'll list them out. So we've got 1, 4, so 9, 4 times 4 is 16, 25, 36. I'll keep listing, 49, 8 times 8, 64, 81, and I'll stop at 100. So now notice here, when breaking down and simplifying, we have the square root of negative 121. Well, if I were to break this down, this is the same as the square root of 121 times the square root of negative 1, right? Because that would give you negative 121. Now notice, what is the square root of 121? It is 11. It's a perfect square. And then notice how we have the square root of negative 1, which is I. So the final answer, the square root of negative 121, is not just 11, right? But 11I to represent our imaginary value. So then here, notice how you have a negative on the outside. Well, this is the same as like negative 1. So keep in mind, we're multiplying our final answer by negative 1 at the end. Now let's break this down. We're still looking for the radical of negative value. So I'm going to first break it apart, right? So this is radical 96 times the square root of negative 1, which again, we know the square root of negative 1 is I, right? So keep in mind, we do have I. Then I'll break this down, radical 96. Which of these perfect square factors, starting at the largest, right? And if you need to use the calculator, right? Divide out. Which of these perfect squares is a factor? 16. The square root of 16 times square root of 6 would give you that radical 96. And here now I've got the square root of 16, which is 4. So now I've got 4 radical 6. Now, so notice how we have all these different pieces, right? I've got negative 1 times, so bringing down my negative 1, and then don't forget I. So we're going to write this officially as with the radical. This is negative 1 times 4, so negative 4I. Keep that together, and then radical 6. So this is how to make sure mathematically to write your final answer. So then here, notice how we've got our coefficient here of 5. So make sure to bring that down. Don't forget about that, right? So now let's break apart our square root of negative 125. Well, that's the same as radical 125 times radical of negative 1. We know that in the end, square root of negative 1 is I, right? So keep in mind, we have the square root of negative 1, which is I. Let's go ahead and break down the square root of 125. So which of these factors, perfect squares, is a factor if I were to divide? 25. The square root of 25 times the square root of 5. That would break down from square root of 125. Then the square root of 25 is 5. So 5 radical 5, but don't forget, right, to continue and bringing down that 5. So 5 from our coefficient, 5 times 5. Oh, and I'm sorry, guys, I forgot about I here. So now organizing and writing your answer, 5 times 5 is 25. So 25I radical 5. So now looking at the last one here, again, notice how you have that coefficient of 1/4. So don't forget to multiply your final answer by 1/4. Let's go ahead and separate it if I'm finding the radical of that negative value. So that's the same as square root of 128 times the square root of negative 1. So again, notice we will have an imaginary value. So this means here, breaking it apart, which of these values is the perfect square is a factor? 64. If I were to divide 128 by 64, you get 2. So square root of 64 times square root of 2. Square root of 64 is 8. So 8 radical 2. Then notice how, right, we have that 1/4. So multiply by 1/4. And of course, don't forget I here. So now we can multiply and finish our simplifying. 1/4 times 8 is 2, so 2I radical 2. Now go ahead and pause the video here and try these 3 U tries on your own. And let's see how you did. So notice again, you are finding square root of negative 12, which is the same as the square root of 12 times the square root of negative 1. So again, notice how we have that square root of negative 1. So here we have our imaginary unit. So we're going to have I. Then breaking down, you could have used the square root of 4 times the square root of 3, right? Because what's the square root of 4? 2. So 2I radical 3 is what you should have gotten here. Now looking at number 2, notice how in the end you should have multiplied by that coefficient of 2. So again, breaking this apart, this is the same as the square root of 36 times square root of negative 1. And again, notice how you will have the imaginary unit, so I. Square root of 36 is just 6, right? But 2 times the 6, and then I from square root of negative 1. That's why we have 12I. Then our third one. Notice again here, we had a coefficient of negative 1/3. So remember to multiply your final answer by negative 1/3. Then notice I'm finding the square root of a negative value. So that's the same as the square root of 63 times the square root of negative 1. And again, you have I here, that imaginary unit. Breaking this apart, we could use the factors of 9 and 7. So square root of 9 times square root of 7. And then again here, the square root of 9 is 3, right? But don't forget, we do have that negative 1/3, right? From our coefficient times that 3 radical 7. Then of course, don't forget I. Now when we multiply, you have negative 1/3 times 3, which is negative 1. So we can just write that as negative I, then radical 7. Because remember, with the negative, it's understood to have that negative 1 value here, okay? And now we're getting into, you could also write complex numbers. So complex numbers, again, using the imaginary unit, but also include real numbers. And a complex number can be written in the form of a plus or minus bi. This is our standard form of a complex number. So it can be written as a plus bi or a minus bi. So that's what that means here, where a is always going to represent the real part and B is going to represent the imaginary part. So again, notice how all of our numbers, if you think about it, can be written as a complex number. So here, for example, I'm identifying the real and the imaginary parts. So notice how I don't have I here. Ooh, notice how I don't have I here. It's just -4, right? So that means the real part is -4, meaning the imaginary part is 0. But then notice how here we do have I, right? So the real part now is 0, and then the imaginary part is 3. All right, because again, we have that 3I. Now here, notice the real part. So the real part here now is +5, and the imaginary part is 6, being that coefficient, right? Because of that 6I here. So now go ahead and pause the video, fill in this table, and then let's see how you do with identifying the real and the imaginary part of each of our complex numbers. And here we go. Now, I noticed before we get started too, that there were 2 complex numbers that were not in standard form. So before we get started on filling in the table, let's identify and see if you also saw what 2 complex numbers were not in standard form. 7I minus 1, that is one of them, right? Because we need to be in the form of A plus or minus BI, where the real part is always first and imaginary is always after the plus or minus. So I'm going to rewrite this now. Keep the sign in front connected. So our real part here, so it's not just 1, right? Keep that sign in front. So that is -1. Notice how 7I is positive, so -1 plus 7I. Then you should have also noticed when looking at these complex numbers, the last column is also not in standard form. So rewriting this again, notice how here we have a +4, so 4. And again, we also have +6I, so 4 plus 6I. Now let's go ahead and identify. You should have here gotten -3 as the real part and +2 because of our I here, so 2. Real part here is just 5 and 0 being our imaginary part. Versus the next one, right? The real part is 0 and the imaginary part is -3 because again, that -3I. And the next one now, notice how because of it being in standard form, right? Now the real part is -1 with the imaginary part being 7 because +7 because again with that 7I. Then the real part, -5, we'll keep the sign in front, right? So the imaginary part's not just 2 but -2 because of that -2I. Then the last, again, now after we wrote it in standard form, the real part here is +4. Imaginary part is +6 because again of that +6I.